Hello and welcome back to Tech and EduSpark Hub, where technology meets education. Have you ever wondered how the differential calculus works? In today's lesson, we'll be looking at the differential calculus, also known as differentiation. So under this lesson, we'll be looking at the general method and other methods of differentiation. So stick with me till the end and let's enjoy the best out of the lesson. So what do we understand by differentiation? By definition, differentiation is the change in parameter or a variable with respect to another parameter or another variable. So that is a simple definition of differentiation. So let's take for example and let's explain this together. So for example, if we have something like y equals to f of x, so you can see this y is a variable because it is equating to another function. So this y is equal to the function of x. So the differentiation is giving us, or the change in y with respect to x is giving us the y over the x. And it can also be giving us f prime of x. And also it can be giving us change in y over change in x. So this is a way you can express differentiation. So when they give you a function as seen on the board, you can see we have a variable which is y equals to the function of x. So we can say the change in y with respect to x is given as what? The y over the x, or is given as f prime of what? X. And also it can be given as change in y over change in x. So this is a way you can express differentiation. But let's say for example we are given a single function like x, and they ask us to calculate what? The differentiation of s. So you can see this one does not have a variable. This is a variable because it is equating to a function of s. So for a single function like this, the differentiation is given as d over the x. So this is the difference. You can see the difference. We have y equals to f of s, and we are giving the differentiation as dy over ds, which is what? Change in y over change in s. But for a single function, and we have to calculate the differentiation will be given as what? D over dx. So this is a way you can easily solve differentiation. Let's say we are given y equals to x squared, and we have to calculate what? The change in y with respect to what? To x. So in this case, they can ask you to calculate f prime of what? X squared. So if they ask you to calculate f prime of x squared, it is still the same thing as calculating what? Change in y over change in x. So they can tell you to calculate what? Dy over dx, or what? F prime of whatever you were given, or change in y over change in x. So this way you can easily solve this question because you just know that once you are given f prime of that function, you are asked to calculate what? The differentiation. But if it is a single function like just x squared, you can see this x squared does not have y equals to x squared. So when you are asked to calculate the differentiation, you just say d over what? Dx, to be given as whatever you get. So this is the difference between a variable and a single function. So let's say for example, we're also given m equals to f of n, and they ask you to calculate the differentiation of this function. You can say the differentiation is given as what? Dm over dn, or you can say it is given as what? F prime of n, or it is given as what? Change in m over change in n. So these are ways you can express differentiation. So question might come and they will give you a function m equals to f of n, and they ask you to calculate dm over dn. You will know that you are asked to calculate what? The differentiation. Or they will ask you to calculate f prime of n. So it is still the same thing as calculating what? The differentiation. Or they might ask you to calculate what? Change in m over change in n. So this is still the same as calculating what? The differentiation of the function. So let's look at the methods of differentiation. And moving to the methods of differentiation, we have 6 methods of differentiation, and I will be listing the 6 methods of differentiation. Let me just write that on the board and you can put that down as well. So here are the 6 methods of differentiation. We have the first one, which is the general method. We have the second, which is the what? The first principle method. And we have the third one, which is the what? The chain rule, which is also known as what? Function of function or function of functions. So that is why I put the x in the bracket. So it is known as what? Function of function or function of several functions. So that is the meaning of that x in the bracket. And we also have the fourth method of differentiation, which is known as what? The product rule. And we have the fifth method, which is known as the quotient rule. And lastly, we have the sixth method of differentiation, which is known as what? The implicit differentiation. So let's look at the first method of differentiation, which is the what? The general method. And moving to the first method of differentiation, we have the general method. So for this general method, let's look at how it works. So let's say we have a variable, which is y, which is equal to what? F of x, and also it is equal to x raised to power n. And we are asked to find the change in y with respect to x. So in this case, in order to find the change in y with respect to x, we know that change in y with respect to x is given as what? The y over the x, which is also given as what? F prime of x. So to get the differentiation of this function, which is x raised to power n, the simple idea is to bring the power, which is n, to the front. So we have the power n to the front, and we'll multiply it with everything that we have initially, which is what? X raised to power n. And the next thing to do is to what? To subtract the power by 1. So this is a way the general method of differentiation works. So you bring the power to the front and you multiply it with everything that you have initially, and you now subtract the power by 1. So in this case, the y over the x will be equal to, so n multiplied by x will give us nx, and we will have, of course, n minus 1. So this is a way to solve the general method of differentiation. So let's look at examples under this general method of differentiation. And the first example, as written on the board, says y equals to x raised to power 3. So we are asked to find what? The y over the x. So in order to find the change in y with respect to x, I said using the general method, the first thing to do is to what? To bring the power to the front. So we have our dy, which is change in y, divided by change in x, to be equal to, so we have to bring the power, which is n in this case. So our n in this case is 3. So we bring the power to the front, which is 3, multiply by everything that we have initially, which is what? X raised to power 3 in this case. And we will now subtract the power by 1. So we have minus 1. So in this case, our dy over the x will be giving us, so 3 multiplied by x will give us what? 3x. And 3 subtracted by 1 will give us what? 2. So this is our final answer to question of this type. So this is how you solve questions on differentiation using the general method. So the simple idea is to bring the power to the front and multiply it with everything that you have initially. And lastly, you subtract the power by 1. So in this case, when we solve this question, we get 3x squared. And this is our final answer to question of this type. So let's look at another example still on the general method of differentiation. And moving to the second example as written on the board, the question says y equals to x raised to power 4 minus 6x raised to power 3 plus 3x squared plus 11. So in this case, the simple idea is to repeat this same concept to everything here in this function. So we have the y over the x, which is our change in y, or yes, which is our change in y with respect to x. So we have the y over the x equals to, so let's do this concept for this x raised to power 4. So the simple idea is to bring the power to the front. So we have 4 multiplied by what? X raised to power 4 minus 1. Because when you bring the power to the front, you multiply it by what you have initially and you subtract it by 1. So we have 4 multiplied by x raised to power 4 minus 1. So we have minus, so the same thing to this 6x cubed. So we have 3 multiplied by 6x raised to power what? 3 minus 1. And we have plus, so we repeat the same thing for this 3x squared. So we have 2, which is the power, multiplied by what? 3x raised to power what? 2 minus 1. And lastly, we have 11. So when you differentiate a constant, you get 0. So a lot will be wondering that why do we differentiate a constant to give us 0? So let me just say it this way. Let's say we have 11. Remember that anything raised to power 0 is 1. So we can write this as 11 open bracket s raised to power 0. Because when we say anything raised to power 0 is 1, it's still the same thing as saying 11 multiplied by 1. So it is still 11. So having 11x, so we have 11x raised to power 0 because x raised to power 0 is 1. So 11 times 1 will give us what? 11 that we are still having. So I just want to prove how we get 0. So 11x raised to power 0. So we'll bring the power to the front. So we have 0 multiplied by 11 multiplied by what? X raised to power 0 minus 1. So in this case, 0 multiplied by everything will give us what? 0. So that is how we get 0 in this case. So let me just clean this. So in solving further, we have 4 multiplied by x to give us what? 4x. And also 4 minus 1 will give us what? 3. And we have this minus. So 3 multiplied by 6x will give us what? 18x. And 3 minus 1 will give us what? 2. And we have plus. So 2 multiplied by 3x will give us what? 6x. And 2 minus 1 will give us what? 1. And lastly, we have plus 0. So in this case, we are having 4x cubed. So our dy over dx will be equal to 4x cubed minus 18x squared plus, so anything raised to power 1 is what? Is that thing. So we have 6x. So we can just ignore this 0. So remember that anything raised to power 1. So anything raised to power 1 is what? Is that thing. And anything raised to power 0 is what? Is 1. So that is the rule. So this is our final answer to question of this type. But we can still factorize it. You can see this. You can still divide everything by 2. So we have equal to 2. We have 2 open brackets. So 4 divided by 2 will give us 2. So we have 2x cubed minus 18 divided by 2 will give us what? 9. So we have 9x squared plus, so 6 divided by 2 will give us what? 3x. So when you factorize, you can get your answer to be this way. So it is not a must that you factorize. You can just factorize if you are doing a theory exam, but it's not a must. So this is giving us our final answer to question of this type. So let's look at our last example on the general method of differentiation. And moving to the last example, under the general method of differentiation, we have the question as written on the board, which is giving us y equals to 8x plus 9. So we have to find what? Change in y over change in x. So this is still the same thing as writing the y over the x. So in this case, we have 8x. So this 8x, you can see there is no power. So it is just telling us that x is raised to power 1, because anything raised to power 1 is that thing, but anything raised to power 0 is 1. So x raised to power 1 is x, but x raised to power 0 is what? Is 1. So in this case, the power here is 1. So we have 1 multiplied by 8x, and we have 1 minus 1 plus, so we have a constant, which is 9. So when you differentiate the constant, you get 0. So in this case, our change in y over change in x is equal to, so 1 multiplied by 8x will give us what? 8x. So we have 8x raised to power 0 plus 0. So this 8x raised to power 0, we said anything raised to power 0 is what? Is 1. So we have our dy over dx to be equal to 8. So x raised to power 0 is 1. So 8 multiplied by 1 will give us 8. So this is our final answer to question of this type. So we ignore this plus 0. So we have the change in y with respect to x as given as what? 8. So this will be all on the general method of differentiation. Attempt this question on the screen and let me know your answer in the comments. I will let you know if you are right or wrong. And if this video helped you understand the general method of differentiation, don't forget to like this video, hit the subscribe button, and turn on the notification bell so you won't miss any lesson or any update from Tech and EduSpark. And in our next lesson, we'll be moving to the first principle method. And until next time, keep learning, keep coding, and I will see you in the next one.